coming to watch the 3D printed advanced session with Dr. Amber Gray and Mr. Zach Lawson. They're the owners of Pixel Power 3D prints, games, and more in downtown Williamsburg. And so they're going to talk to us today about advanced 3D printing. So, Dr. Amber Gray, I will let you get started.
All right, thank you so much for that introduction, Alex. So let me go ahead and share my screen. So thank you again for the introduction. So like Alex has mentioned, my name is Amber and this is my husband Zachary, and together we have a combined 13 years of experience in 3D printing technologies. And so before we get into these more advanced topics regarding 3D printing, I think it's important to understand what 3D printing actually is. So when we look at 3D printing is considered to be a form of additive manufacturing, where in additive manufacturing, what we are doing is we are building up an object layer by layer by layer. And that is what you see up here in these top two videos. These objects are being created, again, layer by layer. And so we can contrast this with another form of manufacturing called subtractive manufacturing, where an example of subtractive manufacturing involves CNC machining, where essentially we are presented with a block of some sort of stock material. In this case, this video is showing a block of metal. And what they are doing with this block of metal is they are essentially carving out their object instead of building up that object layer by layer. And so with 3D printing, there are many different types of processes or methods for 3D printing, but there are two main types available for consumer use. And so those are the types we are going to be focusing on today. So our first type that we're going to be talking about is called fused deposition modeling, also known as FDM 3D printing. And so with FDM 3D printing, this is usually the type of 3D printing that people think of when they think of a 3D printer. On the other hand, we have a second common type of 3D printing called stereolithography, which is often abbreviated as SLA 3D printing, or it's commonly referred to as resin printing. And so today, what we are going to do is we're going to talk a little bit about both of these methods of 3D printing, and we're going to be talking a little bit about some more intermediate to advanced topics within both of these methods. And so first off, let's focus on our most common type of 3D printing, which is known as that fused deposition modeling, or FDM. So with FDM 3D printing, what we are doing to build our object layer by layer is we use these spools of plastic that we see over here. These spools of plastic are called filaments. And so how FDM 3D printing works is we take that filament and we feed it through this heated nozzle. And so this plastic, it becomes malleable. It becomes squishy whenever it is heated up. And so this filament is extruded out of the nozzle, and we can build up our object layer by layer by layer with essentially this melted or squishy plastic. And so whenever we're looking at FDM printing and the types of models that we could print with FDM printing, one thing that we need to note is that a lot of these models need to have supports. And so why do we need to have this support material on our models? Well, like I mentioned, we are building up this model in layers. And so you could see here that in this top image, we have layer 1, 2, and 3. And we see that these layers build up on top of each other. But once we get up here to layer 4, we see that layer 4 juts out past that third layer. We call that an overhang. And so because this plastic is melted essentially when it comes out of that hot end nozzle, due to gravity, if there was nothing down here to support this overhang, it's simply just going to droop down. And so that droopiness is is not going to allow you to build subsequent layers, layer 5, 6, and 7, and so on and so forth, on top of it. And so to prevent that drooping of the overhang of layer 4, you need a support material. And so when we look at supports and supporting our 3D models, we often want to try to avoid using supports. This is because supports can simply just be hard to remove. Furthermore, supports can scar your model and make them not as nice to look at. And so one of the methods that we can use in 3D printing to avoid scarring our model and making the use of removing these supports easier is we could use an alternative material, a different type of plastic than the plastic we are using to print our actual model out with to print those supports. Note, we can only do this if we have a multi-nozzle printer, so a printer with more than one nozzle in it, or if we have something called an automated materials system or an AMS system. And so a lot of times whenever we bring in our model in our slicer to be sent to our 3D printer, oftentimes you can orient your model in a way to just avoid the use of supports altogether. And so down here, if we focus on this left image, so this purple block here, let's say that I want to print that model out on my FDM 3D printer. And so we're printing out this model, and it's going to be printed out on our build plate here, which is represented by our black line. If our model is oriented within this direction, it is going to need supports because you see that we have this overhang right here. And so based on what this particular model looks like, we could actually avoid using supports. How can we do that? Well, what we could do is we could take that model and we can rotate it 90 degrees to the left. And so if we rotate it 90 degrees, we get our object in a position that is shown here within this middle panel. And so looking at our object here, and again, this black line is representing our build plate, what we are printing our layers out on, we would see that our object here in the middle is not going to require supports. There are no overhangs. However, the way that we are printing this particular object would actually come out a little bit weak. And so why would this be considered weak? Well, whenever you're looking at a FDM 3D print, the weakest part of your print is between your layers. And so if we look at how this model would be printed out on a 3D printer, we're building a layer, and so on and so forth. And we're going to have a layer between this kind of longer, skinnier piece and this fatter piece here at the bottom. And so between this layer connecting those pieces, that print is going to be very weak there. And so if I was printing this part out to be used as a functional piece, as a mechanical part, that mechanical part would be very prone to snapping right here between this long, skinny piece and this kind of more fatter square piece at the bottom. So what we could do to strengthen that part is we can orient it in another way. So how about we take this model in the middle and we rotate it yet again 90 degrees. And so if we rotate it 90 degrees to the left, our model will be setting on our build plate as demonstrated over here on the right. And so looking here at the model on the right, we're going to see that this model still requires no supports. There are no overhangs, but yet this model is going to be stronger than the way our model was oriented in the middle over here. And that's because those layers are being printed out parallel to that build plate. And so it's going to be a lot harder to snap off this kind of longer, skinnier piece from this fatter square piece. And so we can keep in mind that we can orient our models in a way in our slicer to avoid the use of supports altogether. And not only that, but we can increase the strength of our 3D printed parts. And so speaking a little bit about FDM printing, so there are different types of consumables that we have to keep in mind whenever we want to print out something with an FDM printer. So our first consumable is the actual filament that we're printing out with. But another type of consumable that most people don't really think of is your actual nozzle. That heated nozzle that extrudes out your filament is considered a consumable. And over time, you will eventually have to replace that nozzle. This is because over time, as you keep printing, your nozzle is going to degrade. Sometimes your nozzle may crash into your build plate, which causes it to bend. And so if you have a degraded nozzle or a bent nozzle, you're more than likely going to experience print failures. And so these nozzles are replaceable. And so when we're looking at these nozzles, we want to note that they can come in different sizes. We could have different nozzle diameters. And so the reason why we would want different nozzle diameters is so we can print at different layer heights. And so we have an example here with this picture of the same object being printed out with different diameter nozzles. And you could see that the smallest diameter nozzle, this 0.2 millimeter nozzle, we could see that the layer height is really small compared to the layer heights printed out by this 0.8 millimeter nozzle. And so you can achieve greater detail with a smaller layer height. And so that smaller layer height comes from using a smaller diameter nozzle. Furthermore, nozzles also are available in different types of materials. So the most common types of nozzle materials include stainless steel or brass. But some materials, some filaments that you may want to print out with may contain abrasive particles. For example, you could have exotic filaments such as carbon fiber filament, which is really strong, or even filaments that contain wood particles within them. So your 3D print looks like a piece of wood. So these abrasive filaments require a really strong nozzle. And so these are just some items that you can keep in mind whenever you go to replace your nozzle within your FDM printer. And so now we could talk a little bit about common print failures and ways we can mitigate those common print failures. And so a lot of times print failures result from a very poor quality first layer. And so if we look at this top image here, we see the first layer of a 3D print being deposited down or extruded out onto a build plate. And so that first layer is very paramount to the rest of the layers that you're printing, because if you have a bad quality first layer, then it's just going to make it that much harder to print those subsequent layers on top of it. And so when 3D printing with an FDM printer, we always want to make sure to stick around to see how that first layer is being deposited down. If we notice the first layer is not being deposited as evenly on that build plate, there are a couple of reasons for this. So the first reason results from something called an improper Z offset. An improper Z offset, or a Z offset, is basically just how close or how far away your nozzle is from that build plate. And so to get our nozzle the optimal distance from our build plate, one of the things that we can do to ensure this is we can make sure that our build plate is level. And so many new 3D printing technologies that are out today, they contain automatic bed leveling features. But if you have a cheaper 3D printer, or if you have a 3D printer that is older, you may have to go in and mechanically level that build plate yourself. Another reason that could result in a bad first layer is a dirty build plate. And so the build plate that these layers are being deposited on can become dirty over time. They could also become dirty if you touch them with your bare hands. Oils from your hands can deposit on that build plate, making it hard for that first layer to stick on there. So to mitigate this, we can simply clean off our build plate with some sort of detergent, such as Dawn dish soap. Another very common print failure is what we call crunchy 3D prints. And so sometimes you may go to a 3D print and it may look complete on that build plate, but when you take it off of the build plate, it may crunch in on itself, essentially becoming unusable. If you come across a situation like this, more than likely that is caused by under extrusion of the filament. Under extrusion of your filament out of that nozzle is more than likely going to be caused by a clogged nozzle. And so to fix a clogged nozzle, we can, one, either just replace the nozzle altogether, or two, we could take a really thin needle, such as an acupuncture needle, and we could use that needle to unclog that nozzle. And so our filament is being extruded out at the proper amount. A third common type of print failure is called elephant's footing. And so elephant's footing is basically whenever you go to 3D print out an object and the first couple of layers is squished out a little farther than the subsequent layers above it. Usually this is not an issue when it comes to 3D printing decorative items or items such as these little flexi toys. But if you're 3D printing functional parts or pieces that fit together, this is when elephant's footing becomes a big concern. And so most of the time, elephant's footing is again caused by improper Z offset. Your nozzle is too close to that build plate, squishing out that filament, causing it to spread out more so on the bottom. And again, to really fix this, one of the ways we could do that is to make sure our build plate is completely level. Our fourth type of common print failure involves the warping of our 3D printed model. And so when our models are being printed on our FDM printers, that build plate or that bed that the model is being printed on is heated. And so if you open your door really quick and have this really drastic change in temperature when going to the room that you store your 3D printer in, that drastic change in temperature can cause this plastic to essentially shrink up in on itself, which warps it. And so one of the ways we could mitigate this is we could place our 3D printer in some sort of tinted enclosure to avoid any drastic changes in temperature. Furthermore, we could use something called a brim. A brim is basically just a very thin layer of a filament kind of deposited around the actual model you're printing. That brim is going to increase the surface area of your model to the build plate, allowing that model to essentially adhere onto that build plate stronger than it would if you just had the model itself alone, thus preventing that warping. And then lastly, and this is most likely probably the more common 3D printing misprint, is a layer shift. And in our experience, layer shifts are due to our print head printing way too fast. If our print head is printing really fast and moving around really erratically in our 3D printer, then that print head can potentially bump into your model and kind of move it out of the way, meaning the subsequent layers being printed on top is not being printed in the place where you would expect it to be printed at. And so the easiest way to fix this is by simply slowing down your print speed. You could adjust this in your slicer, and a lot of newer 3D printers out nowadays, such as the ones that we own, actually allow you to adjust your print speed on the fly as your printer is printing. And so you can monitor this and adjust your print speed as needed to avoid these drastic layer shifts. Additionally, layer shifts can often be caused by loose mechanical parts, such as loose belts. So making sure your printer parts of the printer itself is tied up to its specifications can help you avoid these layer shifts. And so lastly, with FDM printing, there are many different types of materials out there that you can use for your filament. However, the three most common types include PLA, PETG, and ABS. So if you are a beginner at 3D printing, more than likely you're going to be printing out with a material called PLA. PLA is very cheap. It is also very easy to print with. However, the downfall of PLA is that it has fairly low heat resistance, meaning if you want to 3D print out an object to be used outside or in your car, you would not want to use PLA because it can deform in the heat of the sun. So if you want an object for outdoor use, you would most likely want to use PETG or ABS filaments. PETG and ABS filaments are both stronger than PLA filaments, and they are also more heat resistant than PLA filaments. However, both of these types of filaments, PETG and ABS, are harder to print with. So if we look at ABS, something else to note about ABS filament is that it does release fumes. And so if you choose to print with ABS material, your printer needs to be in some sort of enclosure that is ventilated out to the outside, just so you're not breathing in any toxic fumes. So now we are going to talk about that second method of 3D printing called stereolithography 3D printing, or SLA, or resin printing. And so over here on the side, you could actually see a little video of what the process of SLA printing looks like. And you can see it's going to be drastically different than the method that we use for FDM. So what we are using in SLA printing is we essentially have this vat, and this vat is filled with this photopolymeric resin, and this photopolymeric resin cures, or it hardens, whenever UV light shines up on it. And so this vat has a clear plastic bottom, and this clear plastic bottom allows a UV light to be shined up through the vat, and this UV light is going to be shined up in a specific pattern. And so we can cure these specific patterns to build our 3D printed object layer by layer by layer. And so one of the really great upsides of SLA printing is that SLA printers print at an incredibly small layer height when compared to the layer heights involved in FDM printing. And so what this allows is this allows us to achieve great detail within our 3D printed models. And you could see that here within these images, where these prints, we could see that they're highly detailed. They're very smooth compared to our FDM prints, where most of the times within an FDM print, you can actually see each individual layer. Those individual layers are much harder to see within an SLA print, and that's due to the very small layer heights. However, the big downfall of SLA printing is that it involves a lot more post-processing. So when we print with SLA, it is almost impossible to avoid the use of supports. So we have to take into account that we have to remove those support materials from our model. But we have a couple of more steps to follow before we actually have a finished 3D resin print. And so just briefly walking through those steps, right here we have a fresh resin print right off the printer. And so what we would do is we would scrape this print off of the build plate, and then what we would do with that print is we would put it into a wash bath. That is so we could wash off any uncured resin. And so what we use to wash our resin prints is a solvent. The most common type of solvent used is isopropyl alcohol, simply because it's very abundant. You could go to Walmart and buy as much as you want. It is also fairly cheap. And so one thing that people often overlook with resin printing is they often forget that you could do this washing in multiple steps. So the more steps you do your washing in, for example, me and Zach, we wash our prints in a 3-step washing method. So the more steps you involve in your washing, the cleaner those prints are going to be, and the more aesthetically appealing they are going to be to look at once you go to the final step, which is where you finish curing those resin prints. And so even though your resin prints are cured from the printing process itself, these resin prints are not going to be fully cured, meaning they're not going to be safe to the touch with your bare hands Furthermore, they're more than likely going to be pretty soft and flexible. So to further harden those 3D printed resin prints, we put them into a cure station, where within that cure station, we are simply exposing that print to more UV lights to further harden it up and cure it. And so with SLA printing, the actual orientation of your models is incredibly important. That is because when we print with an SLA printer, we want to make sure that we're minimizing the surface area of each layer that we're printing out. We want to minimize surface area to avoid any suction forces from that 3D printing method itself, because these suction forces can come in and deform your model, resulting in a model that's not nice to look at. And oftentimes these suction forces can just completely cause your model to misprint altogether. And so we want to orient our model in a way in our slicer to minimize the surface area of each layer that is being cured. Furthermore, by orienting our model, we can hide those support marked scars. And so within these first two photos here, you could see, if you look closely, you could see all these little gashes and all these little nubs within these 3D printed resin models. Those nubs and gashes are due to the supports that we have to remove. And so oftentimes with SLA printing, people will orient their model to where the supports will be on the part of the model that's not really seen. So over here on the build plate, we see this model is oriented diagonally, where most of the supports are on the back side of that model. So we don't have any of those gashes or nubs on the front side of it. Additionally, with SLA printing, if you want to print out a larger model, you may want to consider hollowing your model. Your slicer should give you options to hollow your models out. This is a great choice to make because you are reducing the surface area of each layer. Thus, you're reducing the chance of print failures due to any strong suction forces. Furthermore, you save money by hollowing out your models because you save on how much resin you use. However, one thing to note is if you hollow your models, you need to put holes in them. So any uncured resin trapped up in that model can eventually drain out during the cleaning process. If you fail to put drainage holes in your model, over time that resin, that uncured resin within the model that's trapped in there, can evaporate and build up pressure and cause your models to crack, which is what we're seeing here within these 3 different resin models that's being shown. We see these cracks due to trapped resin within those hollow models, causing them to split open over time. However, with SLA printing, another big thing that we have to be concerned with is safety. Resin is considered to be a sensitizer, meaning that if you continuously are exposed to this resin, you can eventually develop an allergy to that resin. And so we don't want that to happen, and so we always want to make sure we're wearing the proper PPE for this. So when dealing with resin, you always need to make sure you're wearing gloves. Specifically, these gloves need to be made out of nitrile. If you use latex gloves, that resin is simply just going to seep through those latex gloves and get through your skin. Furthermore, if you're dealing with resin for an extended period of time and in an area that's not very well ventilated, you may want to consider wearing a respirator just so you're not breathing in any of those toxic resin fumes as the resin or as you are printing out with your SLA printer, and just so you're not breathing in any fumes from your solvent when cleaning. Furthermore, resin is not only toxic to us, but it is toxic to the environment. So we want to make sure we handle our resin waste appropriately. So we want to make sure we never pour uncured resin down the drain. Furthermore, we never want to pour our dirty alcohol baths that we use to clean these resin prints down the sink as well. If you are a school using SLA printing technologies, or if you are a business, to take care of your waste, you could simply find a hazardous waste facility to take that waste in. However, if you're doing this in a hobbyist capacity, that costs money. And so what a lot of hobbyists do is they basically put their waste in a clear tote and set that clear tote outside in direct sunlight. And so we set our waste out in the sunlight for several days. And what that allows is it allows that alcohol from your dirty alcohol baths to evaporate. And it also allows the UV lights from the sun to come in and cure that resin. And once our resin is fully cured, it is then completely safe. We can then simply just put it in the trash to dispose of it. And so these are some things to keep in mind if you choose to do anything with an SLA 3D printer. And so now we have these two common types of 3D printing technologies, FDM and SLA. Which one should you use? Well, it really depends on what you want to print. It depends on your goal. So both FDM and SLA printers, both of those guys can print out functional parts. However, you may want to consider using FDM as your method of printing out functional pieces just because it is inherently less messy than SLA 3D printing. And then there is also less post-processing involved in FDM 3D printing. If your goal is to print out toys or flexible items such as this cute little dragon here, you will definitely want to use FDM as your choice of a 3D printer. FDM prints are less fragile. They're less likely to break if you accidentally drop them on the floor. However, if your goal is to print out really highly detailed statues or even to print out miniatures used for tabletop gaming such as Dungeons and Dragons, what you would want to use is an SLA printer. And again, that's just because we can achieve such a small layer height with SLA printers, and so we could have really great detail within those prints. And so with that being said, that is what we have to present today about 3D printing. We are very passionate about 3D printing technologies, so if you have any questions at all, feel free to stop by our shop in downtown Williamsburg and pick our brains. And so with that being said, I'm going to go ahead and stop sharing my screen. If you all have any questions, we'll be happy to answer them as well.
Thank you so much, Dr. Gray and Mr. Zachary Lawson. That was very informational. So I learned a lot of things that I did not know about 3D printing. And of course, you know, being around 3D printing quite a bit, that was really informational. So I had wondered about the differences there with resin and the different filaments and things. So that was excellent. Again, I will shout out the 3D Pixel store. If you want to see Zach and Amber in person, ask questions about advanced 3D printing technologies. And then, of course, you can always email and get up with them that way as well. So it's amber.gray@ucumberlands.edu. So thank you so much for providing that information today.
Thank you for having us.
Thank you.
Have a great day, guys.
See ya.